continue solution of problem. And today, good day, доброе утро. Today begin with number 115. Y is x to the power 5 times a plus 3x cubed times a minus 2x squared. We must find y prime. I'm sorry. We can use logarithmic differentiation. Find logarithm of both parts of our equation. Natural logarithm of both parts. Then use the property of logarithm. And then find derivative. Don't forget multiply by derivative of argument. Find derivative of argument and put y in the right part. Then substitute the sign of y in this place. Is it clear? Not question.
Yes.
Okay.
Yes.
Answer. Next number 117. What is cosine of x squared? In this place we can not use logarithmic differentiation, but you can use it If you want, I will calculate without this. It means I just find y prime is derivative of square root. It means derivative of u to the power of 2. It is 2 times u prime. I have 2 times arcsine times arcsine prime. Arcsine prime is 1 over square root of 1 minus x squared. You have 2 sine of x over square root 1 minus x squared. Is it clear?
Yes.
Yes.
119. Y is arctangent of 2x over 1 minus x squared. Must find y prime. We know that derivative of arctangent, it is minus 1 over 1 plus u squared times u prime. Find y prime is 1 minus over 1 plus u is 2x over 1 minus x squared. I'm sorry. Times u prime. Equals I multiply by 1 minus x squared squared, numerator and denominator of our quotient. We will have minus 1 minus x squared over 1 minus x squared plus 2x squared. Here we have derivative of quotient. It means x prime times 1 minus x squared minus x times 1 minus x squared prime over 1 minus x squared squared. We can take 1 minus x squared out, and we will have minus here 2 times x squared is x prime is 1, this 1. Uh, 1 minus x squared, just write down minus derivative of 1 minus x squared is minus 2x, and this minus gives us plus 2x times x is 2x squared. Okay. Here, open the bracket. 1 minus 2x squared plus x to the power 4 plus 4x squared. 2 squared is 4. All. We will have minus 2 times 1 minus x squared plus x squared. Here 1 plus 2x squared plus x to the power of 4. In numerator we can take x squared out, delete it, And here we have full squared 1 plus x squared squared. And we have minus 2 over 1 plus x squared squared. Is it clear? Understand it?
Yes, understand.
Okay.
Yes.
1, 2, 1. Next function, y is a cosine of x over x. Maybe for verity I use the logarithmic differentiation. Find logarithm of y is logarithm of r cosine of x minus logarithm of x. Find derivative y prime over y equals 1 over r cosine times minus 1 over square root of 1 minus x squared minus 1 over x. And y prime will be equal to y is r cosine of x over x times this expression. Maybe open the bracket. We will have minus 1 over x square root of 1 minus x squared and minus r cosine of x over x squared. Very easy. Do you understand the solution?
Yes.
Okay.
Yes.
Now I give you the photo of both in the chat. You can do it yourself if you will use Okay, I gave you, look, can you see the boat
Yes.
in the
Yes.
chat?
Yes.
Okay. Maybe I will check you right now. After then we continue. In this class exist Abdallah Yusuf Ahmed Al Said Hasni here, yes. Abdul Salam Mohammed Ahmed not. Abdurrahim Allah here.
Yes, I'm
Abdurrahman
here.
Marwan not. Al Abdali Mohammed Hassan Mohammed Ahmed not. Ali Yasin here. Al Badri.
Yes, I'm here.
Al Saidi not. Ahmed Ibrahim not. Ashri Mohammed not. Bin Aoun here. Daoud Abdurrahman
Yes.
here. Davidar not. El Misiri not. Kulyar not. Marzuk Mustafa not. Mohammed Abdurrahman here. Radwan Hamza.
This.
Yes, I can see. Radwan Hamza not. Ramadan Ahmed not. Ramadan Mohammed not. Resk Ahmed here. Sagair Hussein here. Parahat Assama not. Hassan Mohammed here.
Miss.
Hussein Khalid. Shenoda here.
Doctor.
Yes, Silvash not.
Ramadan Ahmed here.
Ramadan Ahmed here. Okay. I save it. Continue.
Doctor, Al-Badri Bakir here.
Al Badr Baki.
Yes.
Okay. I check it you.
Okay, thank you.
Continue.
Risk Ahmed, Doctor, do you check me?
Risk Ahmed, I check it too. Next.
Miss.
100.
Ya Marzuk Mustafa.
Marzuk Mustafa. Marzuk. Okay, I check it.
Спасибо.
123. 123. What is x times square root of a squared minus x squared plus a squared times arc sine x over a?
Doctor, I'm Khalid Hussein. You check me?
Who?
Hussein Khalid, you check me?
Yes, I checked.
Thank you.
Find y prime. Here we can see product of two functions x and a squared minus x squared. We can find product as u prime v plus uv prime, and we have x prime times square root of a squared minus x squared plus x times derivative of this root. And into our second term, we can see a squared times arc sine, but a squared is constant, because each a squared we can take out derivative and find derivative only of arc sine of x over 2. I'm sorry. Derivative of x is 1. Write down just a squared minus x squared. Then x just rewrite Derivative of square root. We can find derivative of square root is 1 over 2 square root of u times u prime. It means we can write down 1 over 2 square root of y squared minus x squared times y a squared minus x squared prime. All of this equals what we can see. This root a squared minus x squared, then derivative of a squared minus x squared is minus 2x. We will have minus 2x and this x, minus 2x squared, over 2 square root of a squared minus x squared, delete 2, and we have square root of a squared minus x squared minus x squared over square root of a squared minus x squared. We can make one quotient, or we cannot. If you want, I do it. We have a squared minus 2x squared over square root of x squared minus x squared. Is it clear?
Yes.
Very good. Next example. Next, number 195. U is arc cotangent of V plus A over 1 minus A times V. Find derivative of arc cotangent minus 1 over 1 plus argument squared. Then we must multiply by derivative of argument. In argument we can see the quotient. Derivative of quotient, it is u prime v minus u v prime over v squared. Use this formula and we can see minus 1 over 1 plus v plus a square root over 1 minus av squared times v plus a prime times 1 minus av minus v plus a times 1 minus av prime with respect to v over 1 minus av squared. I multiply both terms of this denominator by this squared. We can see minus into denominator 1 minus av squared plus v plus a squared. Then numerator, derivative of v plus a with respect to v is 1 plus 0, just 1. 1 minus av, just write down, minus derivative of 1 minus a times v is minus a. And this minus give us plus a, v plus a, just write down. We can see into denominator we can stay 1 minus av plus av plus a squared. I just open the bracket. Into denominator 1 minus 2av plus a squared v squared plus v squared plus 2av plus a squared. We can delete minus 2av plus 2av and this minus av plus av. And rewrite this as 1 plus a squared over 1 minus a squared, or plus, sorry, v squared plus v squared plus a squared. Oh, this is answer, not question. No, number 127. Y is x times arcsine of x. For example, use the derivative of product. We can see y prime is x prime times arcsine of x plus x times arcsine of x prime. Oh, x prime is 1, arcsine just write down. Derivative of arcsine is square root of 1 minus x squared into denominator. Oh. Next, 129. F of x equals arcsine of square root of sine of x. This is composite of two function arcsine of u, and u is square root of sine of x. Find derivative as derivative of composite of function. F prime of x is derivative of arcsine 1 over square root of 1 minus argument squared times derivative of argument. Square root of sine of x squared is just sine of x. Okay. Derivative of square root is 1 over 2 square root argument and times derivative of argument. Derivative of sine is cosine. And in denominator stay 2 and square root of sine I take into this root this sign, we will have sine of x minus sine square root of x. Okay, this is answer. Don't question. Next example, 131. What is e to the power of arctangent of x? You know that derivative of e is e times derivative of argument. Y prime will be equal e times derivative of argument. Derivative of arctangent is minus 1 over 1 plus x squared. Oh, is it clear? Not question.
Yes. That's clear.
Okay. 133. 1 is x to the power of arcsine of x. In this case, we can see x in the base and x in the degree. In this case, we can use only logarithmic differentiation. Find logarithm of both parts and use the degree of logarithm. Then, in this case, we can use derivative of product find derivative of both parts and we have y prime is y is x to the power of arcsine of x. Here arcsine prime it is 1 over 1 minus x squared under square root. Then derivative of natural logarithm is 1 over x. This is answer. Is it clear?
Yes.
Yes.
Next. Y equals arctangent of 4 sine of x over 3 plus 5 cosine of x. Derivative of arctangent is minus 1 over 1 plus argument squared. and we must multiply by derivative of argument. In argument we can see quotient, because we find derivative of argument is derivative of quotient. We will have minus 1 over 1 plus 4 sine of x squared over 3 plus 5 cosine of x squared times 4 derivative of sine times 3 plus 5 cosine of x minus sine times, any question? Derivative of denominator over denominator squared. I multiply this denominator by this denominator. In this case, I can see minus 1 over 4. Oh, not. Minus 4, just this 4. Then multiply one denominator by two denominator. We will have 3 plus 5 cosine of x squared 4 sine of x squared. Okay. Then here derivative of sine is cosine. 3 plus 5 cosine of x, just write down, minus sine, just write down. 3 plus 5 cosine, derivative of this is minus 5 sine of x. Open or bracket. We can see minus 4 times cosine of x times 3 is 3 cosine of x plus 5 cosine square root of x. Minus and minus give us plus 5 sine square root of x over 3 squared is 9 plus 3 times 2, 6 times 5, 30 cosine of x plus 25 cosine square root of x plus 16 sine square root of x. Then calculate this 5 cosine squared plus 5 sine squared is just 5. And we have minus 4 times 3 cosine of x plus 5 into denominator. We will have 25 is 16 plus 9. We have 9 plus 30 cosine of x plus 9 cosine of x squared plus 16 cosine square root of x plus sine square root of x. This trigonometric unit. Here 1, just 1. And we have 16 plus 9 is 25. We have minus 4 times 3 cosine of x plus 5 over 25 plus 30 cosine of x plus 9 cosine squared of x. What do we minus 4 times 3 cosine of x plus 5. Here 25 is 5 squared. 30 is 2 times 5 times 3 cosine of x and plus 3 cosine of x squared. This is full squared. Full squared. 5 plus 3 cosine of x squared. And we can see minus 4 times 3 cosine of x plus 5. 5 plus 3 cosine of x squared. Here we can delete 1 degree of 3 times cosine of x plus 5, and we can see this quotient in the answer. Is it clear?
Yes, clear.
Yes. That clear.
Now I will send to you the board. You have. Can you see it? The board in the chat. Yes, you see?
Yes. Yes. Yes.
Very good. Next example. Number 137. In this number we can see y is natural logarithm. Don't want to write y. Natural logarithm of 1 plus x over 1 minus x to the power of 1 over 4 minus 1 over 2 of tangent of x. We can find y prime. Firstly, I maybe easiest natural logarithm. I can use the degree of logarithm times logarithm as property. Y is 1 over 4 times natural logarithm of 1 plus x minus natural logarithm of 1 minus x minus 1 over 2 arctangent of x. Then find derivative 1 over 4. Oh, sorry. Natural value of 1 plus x is 1 over 1 plus x minus 1 over x times 1 minus x prime. Here 1 plus x prime, but 1 plus x prime is 1. Minus 1 over 2 times 1 over 1 plus x squared. 1 over 4. Here 1 over 1 plus x. Minus and minus give us plus 1 over 1 minus x. Then minus 1 over 2. 1 over 1 plus x squared. Right. Here 1 minus x, here multiplied by y plus x, both part, numerator and denominator. We can see 1 minus x plus 1 plus x, and into denominator 1 plus x times 1 minus x. Okay. Here delete. 1 plus 1 is 2. 2 over 4. In denominator we can see the difference of squared of 1 minus x squared minus 1 over 2, 1 plus x squared. Here take 2 out, 1, 2, and we can see 1 over 2, 1 over 1 minus x squared minus 1 over 1 plus x squared. Multiply by 1 plus x squared, both part, denominator and denominator, and here 1 minus x squared. We can see 1 over 2 times 1 plus x squared minus 1 minus x squared over 1 minus x squared multiplied by 1 plus x squared. Here 1 plus x squared minus 1 plus x squared, here minus, over 1 minus x squared squared equals 1 squared is 1, x squared squared is x to the power of 4, here 2, these two, and in numerator 1 minus 1 is 0, and x squared plus x squared 2x squared, and we have x squared over 1 minus x to the power of 4. Is it clear? Not question. Clear or not?
Yes, clear.
Okay. It was example 137, and next 139. Y is 1 over 3 times natural logarithm of x plus 1 over square root of x squared minus x minus plus 1 plus 1 over square root of 3 times arctangent of 2x minus 1 over square root of 3. Find y prime. Maybe firstly I. Simplify it. Y will be equal 1 over 3 times natural logarithm of x plus 1 minus 1 over 2 natural logarithm of x squared minus x plus 1 plus 1 over square root of 3 times arctangent to x minus 1 over square root of 3. Find derivative. Derivative of natural logarithm of x plus 1 prime over x plus 1 minus derivative of natural logarithm of x squared minus x plus 1 is derivative of argument over this argument. Derivative of arctangent is 1 over 1 plus argument squared. Multiplied by derivative of argument. Find. 1 over 3. Долго. Then x plus 1 prime is 1. We have 1 over x plus 1 minus derivative of x squared minus x plus 1 is 2x minus 1. Into denominator stay 2 times x squared minus x plus 1. Okay. Y2. Yes. Close the bracket. Then plus 1 over square root of 3 times 1 over 1 plus 2x minus 1 squared over square root of 3 squared times here square root of 3 is constant because we can take it out derivative and derivative is just 2. Square root of 3 by multiplied by square root of 3 is just 3. This just 3, 2. Multiply all of this. We can see 1 over 3 times maybe 2x squared minus x plus 1. X plus 1 times 2x minus 1. Maybe here don't need 2x plus 1 times x squared minus x plus 1 plus 2 over 3 plus 2x minus 1 squared. Okay. Find 1 over 6, 3 by 2. Then 2x squared minus 2x plus 2 minus 2x squared plus x minus 2x plus 1. Okay, we can break it. Here x cubed plus 1 plus 1. 2 times 3 plus 2x minus 1 squared. Okay. Find 2x squared minus 2x squared, delete. Then minus 2x plus x is minus 3x. And here 2 plus 1 is 3. 3 minus 3x. 3 minus 3x. Here 2, 3 plus 2x minus 1 squared. Here we can take 3 out into numerator and take 3 out into numerator and denominator, and we will see 1 minus x over 2 times 1 plus x cubed plus 2 over 3 plus 2x minus 1 squared. I think this is answer. Next example, it was what? 139. 139. 1, 4, 1. We can see y is arc cosine of x to the power of 2n minus 1 over x to the power of 2n plus 1. Find derivative. Derivative of arc cosine is minus 1 over square root of 1 minus argument squared. Times derivative of argument. Right. In argument we can see quotient. We can use derivative of quotient. Here 1 over square root of 1 minus x to n minus 1. Oh, sorry. Minus 1 to n plus 1 squared multiply by derivative of numerator. It is 2n times x to the power of 2n minus 1. Denominator just write down minus derivative of denominator 2n times x 2n minus 1 and numerator write down. Okay, denominator squared. I take 1 degree of denominator into square root in the first term, first multiply, we will have square root of x to the power 2n minus plus 1 squared minus x to the power 2n minus 1 squared. Multiply by, in this stay x to n plus 1 to the power of 1, and this 2n times x to the power of 2n minus 1 multiply by x to the power of 2n plus 1 minus x to the power of 2n plus 1, which is just 2. Here minus 1 over square root x to the power of 4n plus 2x to the power of 2n plus 1 minus x to the power of 4n plus 2x to the power of 2n minus 1, open bracket, multiply by 2 times 2 is 4, n x to the power of 2n minus 1, here x to the power of 2n plus 1. Simplify. Minus 4n x power 2n minus 1, denominator x to the power of 2n plus 1, and under root 4x to the power of 2n. We can see minus 4n x to the power of 2n minus 1 over x to the power of 2n plus 1, and this 2x to the power of n. Find 4 over 2 is 2, and x to the power of n minus 1, and into the denominator 1 plus x to the power of 2n. It is answer. Is it clear?
Yes. Okay. It's very good. Maybe a little rest, and then we continue. Okay? Okay.
10-minute rest. 10 minutes.
Okay.
Okay.
Oh.
dy over dx. The first example 143. X squared plus y squared equals a squared. We think that x is a variable and y is the function of x. Differentiate both parts of this equation. X squared plus y squared prime with respect to x equals a squared prime with respect to x. X squared prime with respect to x is 2x plus y depend of x because y squared prime is y to y times y prime. A is constant because its derivative is 0. From this 2y, y prime is minus 2x, and from this y prime is minus 2x over 2y, or just minus x over y. Answer: y prime dy over dx is minus x over y. Is it clear? Not any question?
Yes, clear.
Yeah. 145. Y cubed minus 3y plus 2ax equals 0. Differentiate both parts. 3y squared y prime minus 3y prime plus 2a equals 0. Then 3y squared y prime minus 3y prime equals minus 2a. Y prime, here y prime, times 3y squared minus 3 equals minus 2a, and y prime equals minus 2a over 3y squared minus 1. Clear? The method
Yes.
of differentiation. Okay. 147. X to the power of 2 over 3 plus y to the power of 2 over 3 equals a to the power of 2 over 3. Find derivative of both parts. We have 2 over 3 x to the power of 2 over 3 minus 1 plus 2 over 3 y to the power of 2 over 3 minus 1 times y prime equals 0. From this 2 over 3 y to the power of minus 1 over 3 y prime equals minus 2 over 3 x to the power minus 1 over 3. From this 2 over 3 take out, and we have y prime is minus x to the power minus 1 over 3 over y to the power minus 1 over 3, or minus y to the power of plus 1 over 3 over x to the power of plus 1 over 3, or minus cubed root of y over x. Clear? Okay. Next example 149. X cubed plus y cubed minus 3axy equals 0. Differentiate both part 3x squared minus 3y squared y prime minus 3ay minus 3axy prime equals 0. All that consists y prime we must stay in the left part. All in this y prime don't appear in the right part. Maybe minus 3y prime, here y squared plus ax equals 3ay minus x squared. And we will have y prime equals minus ay minus x squared over y squared plus ax. Okay. This is answer. Okay. Next example 151. Oh, in this example, we must find derivative of y with respect to x if cosine of xy equals x. Find derivative of both parts. We will have x prime y plus xy prime equals minus 1 over sum of x y plus, oh, not minus, and we have x prime is 1, x y prime equals minus 1 over sine of x y minus y. Okay. And y prime, it means dy over dx will be equal to minus 1 over x times sine of xy minus y over x. Is it clear?
Yes, is it clear?
Yeah, very good. This is method of differentiation of implicit functions. I now send to you the board. Yeah, very good. Next function that we must differentiate is the function represented parametrically. Find dy over dx of functions represented parametrically. And first example is 153. X is a times t minus sine of t, and y is a times 1 minus cosine of t. In this case, dy over dx equals y prime with respect to t over x prime with respect to t. Y prime, this y, a times derivative of minus cosine is just sine of t. Here t, here 1. A times 1 minus cosine of t. This is answer. Sine of t over 1 minus cosine of t. Is it clear?
Yes, yes.
Next. X is 3at over 1 plus t squared. Y is 3at squared over 1 plus t squared. Dy over dx equals y prime with respect to t over x prime with respect to t. Y prime with respect to t equals 3a t squared prime times 1 plus t squared minus 1 plus t squared prime times t squared over 1 plus t squared squared, or 3a 2t times 1 plus t squared minus 2t times t squared 2t cubed, or 3a times 2t plus 2t cubed minus 2t cubed over 1 plus t squared squared equals 3a times 2t is 6at over 1 plus t squared squared. It is y prime with respect to t. Find x prime with respect to t is 3a t squared times 1 plus t, or t prime 1 plus t squared minus t times 1 plus t squared prime over 1 plus t squared squared equals 3a times t prime is 1, 1 plus t squared minus t squared prime 2t squared t squared squared or 3a times 1 minus t squared over 1 plus t squared squared. And our y prime over x prime 6ac over 1 plus t squared squared over 3a times 1 minus t squared over 1 plus t squared squared or 6ac times 1 plus t squared squared over 1 plus t squared squared times 3a times 1 minus t squared. Simplify to we have 2t over 1 minus t squared, and our answer dy over dx equals 2t over 1 minus t squared. Is it clear?
Yes, it's very clear.
157. Oh, it is Newton. Write down. Find the tangents of angles of the slope of tangent lines to curves. Find the tangent of angles of the slope of tangent lines to curves. Uh, 157. X is cosine of t. Y is sine of t. At the point x is minus 1 over 2, y is square root of 3 over 2. Make a drawing. Okay. If x is minus 1 over 2, this y is square root of 3 over 2. It is cosine of t is minus 1 over 2. Sine of t is square root of 3 over 2. It is t equals 2 pi over 3. Okay. The tangent of angle to the slope. Tangent of phi is dy over dx. Dy over dx is y prime with respect to t over x prime with respect to t. In the point t is 2 pi over 3. Y prime is sine of t prime. X prime is cosine of t prime. If t is 2 pi over 3. Equals cosine of t over sine of t. T is 2 pi over 3, or cotangent of t if t is 2 pi over 3 equals cotangent of 2 pi over 3 equals minus 1 over square root of 3. Okay? Yes. Cotangent of 2 pi over 3. Okay. Plot this. Y O X. This is line. Y is sine of x and x is cosine of t. 2 pi over 3 is this. And tangent line. And tangent line. Okay. Okay. This is tangent line. And in this we have the angle phi. I forgot minus. Plus. It means phi is pi over 6. Is it clear?
Yes, is it clear?
Yes, doctor.
Okay, next. 1, 5, 9. X is A times t minus sine of t. Y is A times 1 minus cosine of t, where t is pi over 2. Make a drawing. Find tangent of phi is dy over dx equals a times 1 minus cosine of t prime over a t minus sine of t prime if t is pi over 2. Sine of t over 1 minus cosine of t. If t is pi over 2 equals just 1. It is here y o x. Here pi over 2 pi 3 pi over 2 2 pi. Here y is 2a. this. This arc. Cannot. Just arc. Good. Then next arc. And here too. Next arc. But we need point pi over 2. This. Okay. It is tangent line. Here we have angle phi, and this phi is pi over 4. Tangent of phi equals 1. Is it clear? Okay?
Yes.
Very good.
No.
Да.
Next example. Mm-hmm. 161. Yes. A body thrown at an angle alpha to the horizon in wireless space. Described a curve under the force of gravity. Whose equations are x is v0 times cosine of alpha t y is v0 times sine of alpha t minus g t squared over 2, where g is 9.8 meter over second squared. Knowing that alpha is 16 grades, v0 is 50 meter in second squared, second, sorry, without squared. Determine the direction of motion when one t is 2 seconds, 2t 7 seconds. Make a drawing. Find tangent of phi equals dy over dx. dy is maybe I write down y. Don't want to write. Y is v0 is 50. Alpha is what? Alpha is 60 grades. Sine of 60 grades equals square root of 3 over 2 times t, then minus 9.8 t squared over 2 or 25 square root of 3 times t minus 4.9 t squared. X equals x v0 50 cosinus alpha 1 over 2 and we have dy equals 25 square root of 3 minus 9.8 t over 25. If t is 2 seconds, 2 seconds, then tangent of phi will be equal to 25 square root of 3 minus 9.8 times 2 is 90.6 over 25. If t is 7 seconds, then direction equals 25 square root of 3 minus 68.6 over 25. A minute, please. If t is 2 Sekunden, then x is 25, t is 50 meter. If t is 7 Sekunden, then x is 25 times 7 equals 175 meter. This y x is first direction, okay, and this is second direction, this tangent line. This point. Here 5 first, and this 5 second. Tangent 5 first. Equals 25 square root of 3 minus 90.6 over 25, or approximately 0 0.948. Tangent of 5 seconds equals 25 square root of 3 minus 68.6 over 25. Approximately. Now I go to calculate. One point 012 approximately. Yes. Is it clear?
Yes.
Okay.
Yes, clear.
Now
Yes, doctor.
give you the board, clean it, and check you in this class. Okay, can you see?
Yes.
1 minute. I clean and then check you. Okay, I can see Abdallah Youssef, Abdel Salam not, Abdurrahim here, Abdurrahman Marwan not, Al Abdali Mohammed not, Ali Yasin here, Al Badri here, Al Saidi not, Ahmed Ibrahim not, Ashri Mohammed Khatem not, Binaun here, Daoud Abdurrahman here, David Arshaft not, Al Misiri here, Weliar here, Marzouk Mustafa not, Mohammed Abdurrahman here, Radwan Hamza not, Ramadan Ahmed here, Rizk
Miss.
here,
Miss. Marzouk Mustafa, I'm here.
Marzouk Mustafa, okay,
Here.
okay, I check.
Спасибо.
Sagair Hussein here, Farahat Assama here, Hassan Mohammed here, then Hussein Khalid here, Shanuda here, Ilvarsh not. Save and continue. Next. Now Now we must calculate the increments and differentials of the functions. And the first find the differentials of the following functions. Here. (163) y is square root of 1 plus x squared. dy equals y prime times dx. Y prime is 1 over 2 square root of 1 plus x squared multiplied by derivative of argument, it means 2x dx or x dx over square root of 1 plus x squared. Is it clear?
Yes.
Okay. 165 y is x times natural logarithm of x over 1 minus x plus natural logarithm of 1 minus x. I find it as g of x plus u of x, where g of x equals x times natural logarithm of x over 1 minus x. Find dg of x is g prime of x dx. Use the logarithmic differentiation. Natural logarithm of g of x is natural logarithm of x plus natural logarithm of x minus natural logarithm of 1 minus x. In this case, g prime of x over g of x equals 1 over x plus 1 over x times natural logarithm of x plus 1 over 1 minus x. And g prime of x will be equal to g of x is x times natural logarithm of x over 1 minus x, 1x, 1x, natural logarithm of x, 1 over 1 minus x. Okay? And dg of x equals natural logarithm of x over 1 minus x plus 1 over 1 minus x plus x natural logarithm of x over 1 minus x squared times dx. It is g. What about u? Find dy. dy of x will be equal to dg plus du. dg we find, it is here, natural logarithm of x over 1 minus x plus 1 over 1 minus x plus x times natural logarithm of x over 1 minus x squared. It is g prime plus natural logarithm prime. It means minus 1 over 1 minus x dx, and we can see also after simplify. It means dy will be equal to natural logarithm of x multiplied by 1 minus x. 1 minus x natural logarithm of x plus x natural logarithm of x, just 1 over 1 minus x squared dx. Okay, is it clear? Just find derivative and multiply by differential of x.
Clear, yeah.
Okay, and then we must calculate the increment and differentials of the function. And first, 167. Given y is x cubed plus 2x. Find delta y and dy when x is minus 1, delta x is 0.02. And first maybe find increment. Delta y equals y of x plus delta x minus y of x equals y of minus 1 plus 0.02. It is minus 0.98. Okay, minus y of minus y equals minus 0.998 cubed plus 2 times minus 0.98 minus 1 cubed plus 2 times minus 1. It means minus 0.941192 minus 1.96. Here minus 1 cubed, it is minus 1 minus 2. It means 0.098808. It is increment. Then dy is y prime times delta x. Y prime is 3x squared plus 2x times delta x equals 3 times minus 1 squared plus 2 times minus 1 times 0.02 equals 3 minus 2 is 1. 3 minus 2. Here not x, just minus 2 plus 2. Yes. 3 plus 2, 5. 5 times 0.02 is 0.1. Yes. Is it clear?
Yes.
Yes. Yes. It's clear.
Okay, very good. Very, very, very good. Maybe number 169. What knowing that sine of 16 greatest equals square root of 3 over 2 or 0.866 0 to 5. Cosine of 60 radius is 1 over 2 or 0.5. Find the approximate values of sine of 60 radius 3 minutes and sine of 60 radius 18 minutes. Compare the result with tabular data. Solution. Consider the function y is sine of x. And consider that delta y approximately equals dy. It means y of x plus delta x minus y of x approximate equal to dy. It means y of x plus delta x equals approximate y of x plus y prime of x times dx. Consider x is 60 radius and delta y is 3 minutes. 3 minutes is 3 over 60 radius or 3 over 60 radius times times pi over 180 radius. It means approximately equal 0.0000872 in period. Delta x, sorry, not delta y. Delta x in this. It means y of x. Y of x is sine of 60 degrees plus y prime equals cosine of 60 degrees times the x 0.00087222 very big 2. And we have sine of 60 degrees. It is what? 0.86605. 0.86605 plus 0.000436, and we have 0.86647.1. Is it clear?
Yes, clear.
Yes.
In the second case, if delta x is 18 minutes, it means 3 times 6. Zero point 0.005233, etc. 3, etc. It means sine of 60 and 80 0.8660025 plus 0.00261667. It is 0.868642 approximately. Understand?
Yes.
Very good. Are you tired? A big examples. A lot of examples. Okay?
Okay.
Maybe in this moment we can stop our class.
Okay.
Okay. Goodbye, good luck.
Goodbye.
Goodbye, doctor. Bye.
Bye.
Goodbye, doctor.
Bye.